Hi, welcome to question 6 of the Leave Cert Ordinary Level Paper 2 for 2024. If you want to copy these notes, just send an email to shanetry@gmail.com, like and subscribe to get access to more playlists. So question 6 is kind of a construction question. Part A, 1 and 2 are marked together. They're worth 15 marks on a C scale. The diagram below shows the triangle XYZ, and they've kindly given us that triangle. And part 1 says construct the bisector of the angle XYZ using only a compass and straight edge, and make sure to show all construction lines and arcs clearly. So you'll need your compass, make sure not to rub out any construction lines at the end, even though it might look neater. Okay. So the answer here, I'm going to have made a kind of GIF, trying to explore that. So I'm going to play it here and hope that it works. So you place your compass point on Y, okay, and draw an arc, okay, of more than halfway, okay. You're going to do the same thing by placing your compass where your arc has joined, okay, and then draw a big circle. Okay, now it doesn't have to be more than halfway on the first one. Then we place our compass on Y again, and we draw an arc on YZ. Okay, then place the end of your compass point there, and draw another arc here. When you join those lines through this point here, Y, that's the bisector. Now my editing's kind of off. It doesn't quite necessarily look like a bisector, but it's kind of hard to do in PowerPoint. Okay, so we'll just run through that again. So you place your compass point on Y and draw an arc along YX. Okay, and then after you've done that, you put your compass point on where the XY and the arc join, and draw a large circle. You could draw the full circle if you want, okay? But you're just drawing an arc is all you need. And you're repeating that for YZ. You're drawing a compass point on Y, marking it off on YZ, okay? Then putting your compass point where that arc and YZ meet, and you're drawing the circle, okay? And then you're drawing those points through to get the bisector. And that's it. Okay, so part 2 then, I'll flick over to the next video, you're going to construct the in-center. Now the in-center, if you've done like 2 bisectors, then you should be able to get the in-center. You could bisect all 3 lines. So I'll play this video out, okay. It's a little bit longer and more convoluted. You place the compass point on Y, okay, and draw an arc greater than halfway, actually. This is slightly different. Place the compass point on X and draw an arc greater than halfway, okay. And then join those 2 points of where the arcs meet, and that creates the bisector of the line. Okay, you're going to repeat that for another side. Okay, and then you will end up with the in-center. Now you could do it for all 3 if you want, but you don't need all 3. You just need to repeat that for a different side. Okay, I didn't actually do that on the GIF because it's just quite convoluted. There's any number of YouTube videos that will help with that. Okay, it is tricky to kind of BS it if that's what you're trying to do. The construction is one of these things. If you know them, they can be fairly handy. If you don't, you really are in playing the guessing game. But at least try something. Okay, and that should be the end of that one. Okay, now part B, part 1 and 2 are marked together, and they're worth 10 marks. So the diagram below shows the triangles ABC, and that's ABC, small triangle, and the larger triangle ADE. Now these are similar triangles, okay, and we can use that concept. The triangle ADE, they're saying, is the image of the triangle ABC under enlargement. Okay, now some of the lengths are shown in the diagram. You see this length 6, okay, and it'll be a relationship with AC to AE because it's an enlargement, okay. AE will be 3.5 times bigger. And we know that because in part 1, they say use the length of BC and the length of DE to show that the scale factor is 3.5. So the answer here, the scale factor can be found by the long side divided by the short side. Okay, so we're focusing in on BC and DE. Okay, so the long side there is 14 divided by 4 should give you the scale factor of 3.5. And when you put 14 divided by 4 on the calculator, it does. So you've proven that the scale factor is 3.5. Now, in a different question, they might give you the long side and the short side, and they might say, like, find the scale factor. They've kind of given you the answer. So if you can prove that, and in a way, a lot of people may have just gone, well, they're talking about DE, they're talking about CB, and just divide 4 by 14, it won't be right. And then inverted, divide 14 by 4. And if you get the right number, make sure you show that on the page. That would get you the max. Okay, now part 2, okay, says that the length AC is 6 units. Use the scale factor to find the distance from C to E, okay, from here to here. Now we can use the scale factor to find the distance of A to E. That'll be what the answer is. So the scale factor by the short side gives the long side. Okay, so we know the scale factor is 3.5. We know the short side is 6, and that gives us the long side of being 21. Now, they didn't ask for AE, they only asked for C to E. So we have to remember to take that 21 and then take away the 6 units to leave CE. So it's something that I personally would kind of generally misread a question and forget to do that part. Hopefully you won't be as limited in your reading ability as I am, or sometimes am. Okay, and that's it. The answer is 15 units. Yeah, I think that should be, oh, it's not the end, sorry. So part 3 then is marked on its own. You have 5 marker, but it's a B scale, so it's a low partial or full marks. It says the area of the triangle ABC is 11 units. Find the area of the triangle ADE. Now we're using a different formula here, okay, and it's not given in the maths table, so it might put a lot of people off. The scale factor squared is equal to the area of the large shape divided by the area of the small shape. Now we know the area of the large shape. We know the scale factor is 3.5. If we can rearrange that, okay, so bring the area of the small shape over, okay, it's divided on the right. It'll be multiplied when it moves over to the left, okay. You end up with the k squared times the area of a small shape, which we were given, is equal to what we're looking for. So 3.5 squared times 11 is equal to our area. Put that through the calculator, you get 134.75, and that's it. Okay. So that's the end of question 6. If you want to copy these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists.